All right, folks. It's time for the notes for section 10.3, which is about simplifying radical expressions. Let's do page 1 of those notes right now. So we're going to begin part 1. Here it goes. So recall that the simplified form of the expression the square root of 20 can be found by, and then the sentence cuts off. So let me get my marker. You've done this before. You did it in geometry. We maybe even did it in this class. You did it in 097. What you do is you want to factor the radicand into perfect squares, right? So you're looking at 20 and you're asking, what does 20 factor into? What perfect squares does 20 factor into? Well, square root of 20 can also be thought of the square root of 4 times 5, because 4 times 5 is 20. 4 is a perfect square, and then I can use this rule of radicals where I split up the factors under the radicand and write it as the square root of 4 times the square root of 5, and square root of 4 is 2. Square root of 5 cannot be simplified any further, so that's that. Okay, so that should look familiar. If it doesn't, hit me up in office hours and we can talk more about it. Okay. Now, this whole idea of what does it mean for a radical to be simplified? Remember there was 3 things, and so this is the table that's in the middle of page 1. Let's see, where in the, did my eraser go? Here it is. Here we go. So let's talk about those 3 things. All right, so the first thing, number 1, the radicand cannot have any factors to a power that is greater than or equal to the index. The radicand has no powers greater than or equal to the index. Okay, so for example, if I had this, if I had the third root of x to the 5th, the radicand has a power that is greater than the index. So this is not simplified. Okay, what I can do with x to the 5th is I can think of it as x to the 3rd times x to the 2nd. And then I can split this up and start to simplify that, and that's what we're going to do in the next examples. Okay, but that's the first thing about simplified radical expressions. The second thing, the radicand has no fractions. Okay, this is kind of an easy one. Like if I had this, the 5th root of 1 over 125, that's not simplified because there's a fraction underneath the radical sign. You'd have to do some stuff to take care of that if this was to be considered simplified. Okay, and then the final one is number 3. Let's see. Oh, there can't be any radicals in the denominator of a fraction. No radicals in denominator. Okay, so like if you had something like this, 1 over the 3rd root of 8, that's not simplified because you got a radical sign in the denominator. All right, so those are the rules. The rest of this is going to be working on applying those rules to getting simplified radical expressions. You guys have any questions so far? Good. That's good. Raise your hand if you have a question. Okay. I guess there's no questions. Let's keep going. There's one more thing for this part 1. It says the process in the rule is the same for expressions involving radical expressions of roots higher than 2. Here's the multiplication rule for this. I'm not going to do the whole words, but I'll just kind of do it as an equation. if you have the nth root of something times something, the nth root of a times b, then you can kind of split it up into two separate things, two separate radicals, where you have the nth root of a times the nth root of b. Okay, now, how do we actually use that rule in the process of simplifying radical expressions? Well, that's what we're going to talk about on the next page. This is now the end of part 1. See you later.